You're with Cape Talk.
You're with Cape Talk.
Cape Talk.
Cape Talk.
WhatsApp Clarence.
072 567 1567.
In this particular instance, you're going to be WhatsApping the Naked Scientist, and he can answer those. Welcome, Dr. Chris Smith, the Naked Scientist. Good to have you.
It's good to have you too. Big week for news as well, Clarence. Some lovely stories out this week. What caught your eye?
Well, I've just come out of a conversation with Peter Anderson, our UK correspondent, about Liz Truss and her race with the lettuce.
I haven't heard that one, but what I was talking about this week, which I thought was absolutely stupendous, I don't know if you saw the news of this, but researchers have got the genetic codes of 13 Neanderthals. Now, we only had 18 Neanderthal genetic codes before this, and they found these 2 cave sites in Siberia where there is a whole community, not the odd specimen scattered all over the place. There is a community that were all there at the same time. So they've got these genetic codes from these individuals, and they are related. There's a father and a daughter, there are aunts and nieces, and so on.
Wow.
And why this really matters is that when you can begin to compare the genetic codes of closely related organisations and communities like that, you can begin to learn something about society. Because obviously when we only see a skeleton or we see isolated remains, we learn only a bit about what that individual perhaps looked like, what they would have been adapted to doing, their life and so on. But when you get communities, you can begin to build an understanding of the relationships between groups. And so we're going back 50,000 years here. We're getting an insight into how this group lived, migrated, and what they did 50,000 years ago. The most striking finding, they were quite inbred, so they obviously lived in quite small groups. One researcher, Lara Cassidy, who works on this, who I spoke to, she's at Trinity College Dublin, and she wrote a commentary on this amazing piece of work this week. And she said to me, well, if you look at how mountain gorillas live, they're in small groups, so they tend to concentrate their genes in their groups, and so they become quite inbred. The Neanderthals were quite similar, so it looks like they had similar levels of community size and inbreeding. But when you then compare males and females, you find something extraordinary. You find that the males are more inbred than the females. And what that's telling you in that community is that the women came from outside and joined the community. What she couldn't tell me, though, is that because the blokes are going off and finding a wife, or are the wives coming after the men? We don't know. Time will tell, perhaps.
Indeed. How does that affect the archaeological record? Does it?
It affects it in the sense that it gives us insights into the sort of sociology and the anthropology of these people. It tells us something about their behaviour, how they would have lived, who they lived with. It doesn't affect our overall understanding of the evolution and the timeline. We know that Neanderthals probably split apart from what became anatomically modern humans, i.e. us, about 400 to 500,000 years ago. They were very successful for the best part of 500,000 years. They began to decline by about 50,000 to 40,000 years. They were gone by, at the latest, 30,000 years ago, probably pushed out by us. But of course, their legacy lives on in all of us, because the other thing the genetic codes have taught us is that if we look at the genetic sequences of Neanderthals, and thanks to someone who got the Nobel Prize a couple of weeks ago, that's why we know the genetic codes of Neanderthals, we can then say, well, how many of those genes are also in us anatomically modern humans? And you find the average human picked at random across the planet has about 2 to 3% Neanderthal in them. So we are all a living fossil of part of the evolutionary timeline of our close Neanderthal relatives.
So make peace with that Neanderthal in you is maybe some good advice. We had a mentalist through in the week, and we were seeing, or we were talking about telekinesis, we were talking about telepathy. Is there research that supports such capability of mind?
No, people have done quite good studies on this scientifically. I've talked to and interviewed some of the scientists who've done this, and they cannot find any evidence of this happening. When this is done properly, with properly controlled scientific studies, you do not find that it holds water in any way. The problem is that there's something in science which is called publication bias. which is that just by chance sometimes something extraordinary happens. And because we tend to be obsessed and we attach significance to coincidences quite often, we like positive outcomes. We don't tend to like or favour negative outcomes. You tend to find the stories that get told, the things that get published, are the positive ones where there was something amazing, something jaw-dropping happened. So unsurprisingly, you do get documented accounts where this does appear to happen, and there is no publication of all the times when it didn't. And if you actually do the science properly, you find that there really isn't any water to be held by this.
Wow. Okay, I'm young and I do lots of sport, but consistently have low blood pressure. What can I eat or do to stop this?
You don't need to worry too much about low blood pressure, especially as a younger person, unless you're symptomatic with it. What I mean by this is that your blood pressure is an essential thing. It keeps blood circulating from an area of higher pressure in your heart to an area of lower pressure, which is your veins. And if we didn't have blood pressure, none of us would be alive. Too high a blood pressure, though, bad thing, because it does wear out your arteries, and this leads to a range of problems, including the arteries furring up to your heart, your brain, and so on. But lower blood pressure is a good thing to have unless it starts to cause symptoms. Those symptoms are generally that people feel dizzy and faint, especially when they stand up abruptly or get up from a hot bath, for example, and they can black out or feel dizzy and funny lights in front of your eyes temporarily. If this happens a lot, then perhaps this needs investigating. But for the average younger person, you do run a lower blood pressure because your arteries are nice and elastic and flexible. As you get older, they do stiffen up, and so blood pressure does tend to rise with age. So I would say don't worry about it unless it is causing you a symptomatic problem and perhaps causing you to faint and so on. Then you need to perhaps get that investigated. But otherwise, I would welcome and cherish lower blood pressure because this will keep you living longer.
We're going to take a phone call. Zuki out in Big Bay. Welcome. I'm sure you're missing Refilware, but yeah, it's good to have you on this side. Zuki, your question for the Naked Scientist.
Morning, Clarence, and morning, Dr. Chris. Okay, I'd like to know why do we cry? What is the physiological reason for crying? Why do tears come out of our eyes? Our facial muscles contract. Sometimes there's involuntary sounds. Is there a specific reason why that happens? Because it's not learned. It's obviously some kind of reflex. So what is the reason?
As far as we know, Zuki, that humans are the only animals that do this. And the reason we do this is that we are very visual creatures. We're social creatures, we live together, but we also set great store by what we can see. And part of the reason for this is we have an excellent visual system, and a third of your brain, if we worked out how much of your brain you're devoting to different jobs, in a human brain, about a third of our brain matter is devoted to decoding what we see. So it makes sense, given we're social and we see a lot and we see well, to use a very visual signal of distress. Some animals will use other things. They use sounds, even sounds that we can't hear, for example. Mice scream in ultrasound, for example. Other animals will change their coloration a bit, or they make themselves look bigger. We will use crying as a very visual manifestation to show distress, or in some cases happiness. So it's an extreme of emotion. And because we also pay enormous attention to faces, our brains, other animals do this as well, but our brains are programmed to look very hard at faces. If you show people pictures and you put eye tracking software on so that you can see what things people spend more time looking at, if you show them a picture and it includes a person and the face, their eyes will naturally spend far more time interrogating the face than any other part of the picture. And this is because that's how we tell each other apart. We recognize each other by having a specific brain area devoted just to recognizing faces. So unsurprisingly, we have evolved to use a visual stimulus that shows our emotional distress or emotional heightened state in order to convey that to others because we're a social species.
It's the Naked Scientist, Dr. Chris Smith. Here's a voice note for you, Dr. Chris.
Good morning. This is Gisela from Durbanville. You're talking about Neanderthals and the genetics that we all carry, except Africa. Africans, obviously before they mixed with other tribes, did not have Neanderthal genes in them.
Wow.
Well, the thing that, if we look at the genetic codes of the African continent, you see the greatest genetic diversity there. And this bottlenecks as you go out across the world, and this maps onto what we think from the archaeological record the pattern of human migration was. So we know that anatomically modern humans first emerged from the African continent, probably, although this is a bit contentious, 50, 60,000 years ago. That's when the first anatomically modern humans began en masse forays from Africa. And they took with them the genetics they had evolved at that time. But because that's where people evolved in the first place and populated more broadly, the greatest, widest selection of genes is found there, and then you get this dissemination around the world. And there will be some communities, some populations that have a richer Neanderthal genetic imprint in them, some societies that have a weaker one. And this is important in this era at the moment, because one of the things we've discovered about the new coronavirus that causes COVID-19 is that there are some of those ancient Neanderthal genes that would have been selected by Neanderthals living in Europe by the exigencies of the environment in which they lived that would have made them successful in their environment, but those genes are actually making people more ill if they catch the new coronavirus. There's something about the way in which they affect the functioning of the immune system that in some way renders people who carry those genes more susceptible. And when you look at populations around the world who appear to have heightened COVID cases and risk, you find an escalated or enriched representation of Neanderthal DNA in those populations. So it does really differ where you look around the world, but it has an important impact in the modern era, as well as our understanding of what happened about 50, 60,000 to 400,000 years ago.
Hi, Dr. Chris. Yesterday, Clarence spoke to someone about Sober October. My question is, do I get drunk quicker after a stint of abstinence? And that from Tony.
Hello, Tony. Well, in essence, you would a bit, yes. And the reason for this is alcohol has what we call an inductive effect on metabolism and on the nervous system. Alcohol is a poison, and it is degraded in your body chiefly by your liver by a sequence of enzymes that break it down, and they turn it into initially a chemical called acetaldehyde, which is about a carbon atom and a few hydrogen atoms different from the stuff we use to embalm bodies in the post-mortem room. And then it turns it into vinegar, and then you pee it out. The metabolic process reacts to how much of that toxin is there. So if you drink a lot, you will induce more of those enzymes that do that breaking down process than a person who doesn't drink. Some people naturally have more of those enzymes anyway, which is why they have a higher ability to drink more, tolerate more alcohol, and get away with it for a bit longer, although it does still poison your body. But the other consequence is that when the alcohol gets into your brain, it potentiates or activates the part of the brain signaling system that is inhibitory. That's why it's called a CNS depressant. It makes you feel sleepy because it activates your brain's natural inhibitory system. And because your brain knows that the inhibitory system is being overactivated, it turns down the level itself. And this is why people who drink a lot get into the habit of drinking a lot, and if they stop drinking abruptly, they can have fits and other withdrawal symptoms because their brain becomes overexcited in the aftermath. So a bit of alcohol over a sustained period of time will have the effect of making your brain a bit more excitable. And if you abstain, you will therefore reduce the rate of metabolism, and you will reduce the ability of the liver, of the brain to, or you'll reduce the brain's sensitivity to this inhibitory process. So you will effectively get drunk more cheaply and a bit more easily after a period of abstinence, but the effect is going to be very minor and very subtle in a person who is a normal, what we'll say, normal drinker. Someone who's a very, very heavy drinker would probably notice a more marked effect, although probably the effect on their wallet would be more pronounced.
Jonathan joins us on the line from Clovelly. Jonathan, go ahead for the Naked Scientist.
Thank you, Dr. Chris. Yes, my question is that, the problem is that we've got lots of load shedding in this country, but we've also got lots of unemployment. And I wondered if it might be feasible to have whole banks of bicycles like you get in gyms, where people cycle and they generate electricity which could charge a battery or an inverter or a generator or something like that.
Hi, Jonathan. It would be wonderful to try and do that, but when you start to look at the maths, you find that it just doesn't add up, because the output of a person, if a person really goes for it, they might be able to manage 100 watts for a bit. And the wattage of a person just sitting there metabolically at rest is about 2 watt per kilo. So your average person's running about 100 watts anyway. And when they start to exercise, they're probably doing 100 watts of work, give or take. And they can do that for a little while, but you'd have to be pretty fit. When you think about a bar fire, a 1 bar electric fire, that's a kilowatt. So to run your bar fire in your house, you'd probably have to have 10 people pedalling away to do that in a sustainable way for one person's bar fire. So you can quite quickly see that you would really struggle to produce meaningful amounts of electricity that way on the scale that we would need to do that. And the BBC did an experiment a few years ago where they said, let's see if we can keep a radio studio on air just by human endeavour. So people generating the electricity. They couldn't do it. One radio studio. And actually radio gear, although there's lots of nice coloured lights and things, it's all LEDs. It doesn't need a huge amount of current to run a radio studio. The lighting and the aircon actually is the biggest thing, and you can turn that off. So really it comes down to the fact that the amount of energy that we consume as a human race is vast, and that it's way beyond the ken and potential of a human being to generate meaningful amounts that will keep us happy. And it's our addiction to that very profligate use of energy that has unfortunately landed us in the position we're in. Thankfully, there are ways to mitigate this in other ways, because we are moving towards much more economic use of electricity, materials and devices which use a lot less energy and waste a lot less energy. That's going to be the way to go, rather than trying to press gang people into pedaling very quickly to keep your computer on.
Another question in via WhatsApp. If we could weigh the Earth, does it get heavier or lighter, taking note that the atmosphere is part of its weight? And that when a spaceship leaves its parts on Mars or the moon. AB in Goodwood with that question.
Hi, AB. The Earth weighs, in inverted commas, a 6 followed by 24 zeros kilograms. So that's 6 with 21 noughts tons. And the reason we know the mass of the Earth is because we know what it's made of, we know how big it is, we can look at its effect on other objects that orbit and so on, we know how much they weigh, so therefore we can work out what the mass of the Earth must be, to a reasonable degree of accuracy. We also therefore know, based on various measurements and so on, what the Earth is doing in terms of mass every year. Every year a couple of aircraft carriers worth of material rains in from space and adds to the Earth's mass. So the Earth is gaining material from outer space in the form of micro and macro meteors, which come down from space and land on the Earth. When a space rocket leaves the Earth, it will take some mass with it, but the amount of mass of a space rocket compared to something that is 6 followed by 21 zeros tons is inconsequential. What's more of a consequence is that every second the Earth is losing tons and tons and tons of very light gases like hydrogen and helium from the upper reaches of our atmosphere, because the gravity of the Earth is insufficient to hang on to those very light gases, so when they get high up in the atmosphere they are whipped away by the solar wind and wander off into space. So overall the planet is losing mass because it is losing those light gases, and it's losing more of those than it's gaining in stuff raining in from space. But there is another thing here, which is that the Earth is also warming up. And because of global warming and the rise in global temperature, because E, energy, equals mc squared, mass times the speed of light squared, if you raise the energy in a system, which the Earth must be increasing its energy because it's getting warmer, therefore the mass must be going up to satisfy E equals mc squared. So although the Earth is losing stuff into outer space in the form of gas, it is nevertheless gaining mass because it is getting warmer. So our overall approximation is that the Earth is gaining a bit of mass every year.
Hi, Dr. Smith. I enjoy my natural documentaries. In the US, lionfish are a dangerous, invasive fish. Divers are killing as many as possible, but seeing that they have no natural predators, it's an uphill battle. Can other fish learn to target lionfish? And that question from Samantha.
Hello, Samantha. Well, the answer is that nature is a wonderful thing. And given enough time, nature adapts to what is thrown in its path and evolves accordingly. And if you think about this, there must have been many examples across the billions of years of evolution of life on Earth, that things have changed and opportunities have arisen, and then something arises to take advantage of that opportunity. We tend to throw a spanner in the works as humans because we make things happen on very short timescales that then really upset the apple cart. But given enough time, things will adapt and readjust. New predators will come along, and this is the nature of the beast, as it were. But in the short term, it can have devastating consequences because we make things happen en masse and in such a rapid rate of time. A good example of this that nature can adapt is that in Australia, the cane toad was introduced there to deal with the problem of bugs that were damaging the sugarcane crop. Because someone thought, well, these cane toads, which come from, I think, South America, are really good at eating bugs. They'll want to eat insects and they breed really fast. Let's bring some of those in and they will eat these annoying pests that are damaging our crops. Unfortunately, the toads are active at night, the pests are active during the day, so they never actually see their paths crossing with the thing they're supposed to eat, so they don't. They are very fast breeders and they're venomous. They're highly toxic. Their skin secretes horrible toxins. None of the Australian native wildlife knows about cane toads, so they go and eat them with abandon and are then poisoned, and it's killed off enormous amounts of the native flora and fauna. But talking to some of the conservation people that I talk to from time to time, they tell me that some animals are getting more savvy now and they flip these toads over and they eat them from the underside where they don't have the poison glands, so they can eat the toad without getting poisoned, and they've begun to learn that naturally. Also, you'll see that there will be some animals will evolve that by chance happen to have resistance to the particular spectrum or constellation of, I think they're called bufotoxins, these toxins that these toads make. And so just by chance, some animals will be more resistant to them. They will not be poisoned, or they will be able to exploit that food source, so they will be more likely to have more babies, which will also carry that trait. So it will enrich that population in the community. We just have to hope that there's enough of those individuals that can do this in order to preserve populations. But yes, nature can adapt and generally does adapt.
I want to squeeze in this question. We've got about 30 seconds to answer it. What's the doctor's thoughts on electric cars? If we all convert to electric cars, will it make a difference to the environment? Seeing that the batteries are emission to manufacture, won't we be better off just sticking to petrol cars? Suleiman, with that question.
Suleiman, the answer is it depends what you're trying to achieve and how you're going to power your car. Because whether it's petrol, diesel or electricity, it's energy, and we need energy to go about our business. Now, the downside of diesel and petrol cars is when you put them on the roads around Cape Town or Joburg, both of which I've had the pleasure of being stuck in huge traffic jams for long periods of time, you end up with enormous amounts of pollution, and that's really bad for people's lungs. If you can use electric cars, you solve that problem. But you only shift the emissions to wherever you generate the electricity. So if you're burning coal to make the electricity to power the electric cars, you're no better off if you don't deal with the output from the coal station. But if you power the electric cars sustainably, solar panels, wind, other forms of electricity generation that are not carbon or pollution emitters, then you've actually got a win.
And that's the Naked Scientist, Dr. Chris Smith. He joins us every Friday at 9:30, and you can throw any question at him and have stuff clarified.